Calc Review Part 1. In this video, we'll talk about all the basics of calculus, basic derivatives, basic integration. In the next video, we'll talk about more about the applications. So first, don't forget what a derivative actually is. It's this formula right here, to give them the limit definition of a derivative. Where the big thing, if you ever see this, you have to understand what that means, which is if I give you a function f of x equals, let's say, 2x plus 1, f of x plus h is just plug this in for the x right there. So 2x plus h plus 1. If you do that, this is going to be fine. You can plug it in, factor, cancel stuff out. Don't forget the derivative of some function is written by f prime of x and gives the slope of a tangent line at any point, right? Derivative is the slope of a tangent line. Instead of saying slope, they'll say gradient function or gradient. It's the exact same thing. But it's a very important concept because if I give you a graph, that's a graph, and I want the derivative at a point like here, I'm like, what's a derivative at 3? Well, you're just going to find the slope of the line at 3. So go to 3, go right here, find the slope. Slope there is 0. If I want the slope right here, you just do rise or run. So keep that in mind. That's all derivative is, the slope of a tangent line. So sometimes you gotta actually find slope the old school way and just do rise or run. The slope of the tangent line corresponds to the instantaneous rate of change. Another key thing, if you see those words, that means derivative. So there's a couple keywords you gotta know, right? Gradient of a tangent line means derivative. Instantaneous rate of change means derivative. All these things mean derivative. A very important concept is what happens when the derivative equals 0. Whenever the derivative equals 0, that's how we find the maximum minimum function. There's actually a couple ways to verify something's a max min. First, if you have a calculator, you can just graph it. Right? Graph your function. Hey, there's a max. Hey, there's a min. Find it using second calculator, and you can find a max or min. So let's do a calculator. Second way to do it is by taking derivative set equal to 0. And we can do a sign chart. So remember the way you do that, you get your critical points A and B. Then you get like you plug in test points, you get like plus, minus, plus. If you go plus to minus, that's a max, relative max. Minus to plus goes down and up as relative min. And then the third way to do it is something IB loves. That's called a second derivative test. So we'll talk about it a little bit right here. So second derivative test, it says this. And we'll talk about it a little bit down here also, actually. So let me move it down. It all essentially says this. So you take your first derivative, set equal to 0. That gives you your critical points. Let's say critical point is A. Now, how do you tell if that critical point's a max or min? That's what the second derivative test comes in. We're going to plug that critical into the second derivative. And you have two options. It could be positive, which means, so where second derivative is positive, that's concave up, which means you have a minimum. Or it could be negative. And when the second derivative is negative, you're concave down, and that's a maximum. So that's the second derivative test. You find your critical points by setting the derivative equals 0, that never changes. Once you hit a critical point, you plug into the second derivative. Positive means concave up, so min, lowest point. Negative means concave down, so max. Again, that's one way IB loves to show the max or min. They like to verify by doing the second derivative test. Let's go up here to finish some ideas off. So keep in mind the first derivative tells us increasing, decreasing. The second derivative tells us concavity. And if second derivative is negative, that means it's concave down, so it's a max. And if second derivative is positive, then it's concave up or a min. Now the way we find inflection points is when the second derivative equals 0. And we have a sign change. So if you do like a sign chart for the second derivative, and you got plus and plus, that would be no inflection point. So you need a sign change. So inflection point is second derivative equals 0 plus the sign change. So that's all little stuff about general important things with derivatives. Now this is going to actually how you take a derivative. Don't forget you get this big old formula sheet. Now notice there is the definition of derivative right there. So if they ever ask you that, you can just plug into the formula. Again, the key thing about that is understanding how to do f of x plus h. If you do that, you're going to be fine. All this stuff is just all the basic rules. There's a power rule. There's a derivative of sine and cosine. So again, you don't have to memorize them. You should. Most of us have it memorized by now, but you don't need to. It's your formula sheet. Derivative of tan is 1 over cosine squared. EDX is EDX. Natural log is a little tricky. 1 over x. This chain rule is the worst version of chain rule I've ever seen. Chain rule is just take the derivative of the inside. So let's say I have something like this. You take the derivative of the outside, leave the inside alone, and then times by the derivative of the inside. Don't forget times by the derivative of the inside. That's the chain rule. Product rule, a lot of people freak out when they see this. Remember, that's u, this dv dx just means v prime. V, du dx just means du prime. So it's essentially just saying u v prime plus v u prime. That's all it is. Derivative of 1 times the second plus the other way around. Same thing here with the quotient rule. Right, so if you're dividing, it's a quotient rule. This again means u prime. This again means v prime. So derivative of top times the bottom minus derivative of bottom times the top, all over the bottom squared. Then our basic integral rules. Now there's less of these. There's no product or quotient. It's all these basic rules and then the u sub. Then if you want area between two area underneath the curve and the volume underneath the curve, and then the total distance traveled from here. So those are all the formulas they're going to give you. We'll use a lot more of these next time. But for now, let's talk about some basic derivatives. So let's find the derivative of this. So the derivative of this one, we're going to use a basic rule to bring the power down, subtract 1 off. So 3/2 times 4. X the common denominator, 2 over 2. So 1/2. Minus 3 times natural log x. Now remember, natural log is 1 over x. So 3 times 1 over x. Minus e to the 4x plus 1. This is a chain rule. Right? Take the derivative of the outside, e is just e. Basically, e just means copy it. Leave the inside alone. Times by the inside. Derivative of that inside is 4. Derivative of cosine is negative sine. And the derivative of 2 is 0. That's going to suck later. Okay, then we just simplify this. 12 over 2 is 6. X to the 1/2 minus 3 over x minus 4 e to the 4x plus 1 minus sine of x. And there we go. Notice no plus c. That is only for integration with no limits. Now the next one here, f of x equals x times sine of x. A lot of people mess this one up. Notice I said x times sine of x. X times sine of x. This is a chain rule, product rule, sorry. U times v. So my u is x. My v is sine x. U prime is just 1. V prime would be a negative derivative of sine, which is this cosine. And that's it, you just put in the formula. So u times v prime plus u prime v. It doesn't matter which one's which. So u is x times cosine x plus u prime 1 times sine of x. There we go. That's the derivative of that one. Good old product rule. This next one's annoying because of the algebra of it. You have 3x times square root of x. Now you could do a little product rule if you want, but the easiest way to do this is this. First you have to rewrite this always. We never leave radicals. You have to change them to x to the 1/2. So now we have that. You gotta remember, to make it easier to yourself, that when you multiply these, you add the powers. So this is the power of 1. You're gonna add it, so 2 over 2. I'm gonna get 3x to the 3/2. Now again, I just did algebra. Haven't done any calculus yet. Just simplified using algebra. I was like, okay, common denominator, add them up. I got this. Now we can do some calculus. Bring this down, subtract 1 off. I'm gonna get 3 times 3/2. 3/2 minus 1 is 1/2. And I get 9 over 2 x to the 1/2. Done. The next one, look at that baby. That's a nested chain rule. There's like so much chain rule going on right there. It's great. So first thing I'm gonna do is rewrite it. So this is gonna be sine 3x all squared. That's the way these work. You want to rewrite it as the square of the whole thing. So you have that. Now it's just a chain rule. Take the derivative of the outside, subtract 1 off. So you have this. Leave the inside alone. Times by derivative of the inside. Derivative sign is negative cosine. Positive cosine. Sorry, I've been doing integration too long. Leave the inside alone. And then times by derivative of the inside. 3. That's my answer. I could clean it up a little bit, make it 6 sine 3x cosine 3x. But that's the general idea. And actually, I don't want to clean up that way. You can see this, they might ask you this at some point. If you notice this, that is the same thing as the sine 2 theta formula. So I could actually write this as a more, if I was pro, as sine 2 times 3x times 3, which gets me 3 sine of 6x. That's actually probably the most complete way of answering this. And you're like, if you're going, what's going on there? There's a formula in your formula sheet that says this. 2 sine x is 2 cosine x sine x. And that's what I had here. I had 2 times sine times cosine of the same inside. So I could just use that formula to simplify it a little bit. Again, it's like an advanced move. The next one. Now this, you might think it's quotient rule, and you could do quotient rule this, but there's an easier way. You could separate these. Now, you can only do that only when the bottom is a single term. It could be 2x, it could be 3x, but as long as it's a monomal, you could do this. So I could separate it like this, using some algebra tricks. That should be minus. Right, so again, notice I'm just doing some algebra. I haven't done any calculus yet. This is going to be 5x minus 3. I'm going to write that, move that to the top and make it 2x to the negative 1. Now again, a lot of people get stuck when it's like, okay, they'll finish off right there and like, no, we haven't done any calculus yet. How's this algebra? Let's take a derivative now. Right, derivative 5x is just 5. Derivative 3 goes away. Derivative this, bring it down, subtract 1 off. Negative 2x to the negative 2. There you go. Now this next one I can't use the same trick because down here it's a polynomial, it's a binomial there. I can only do it when there's only one term on the bottom, like 2x, 3x, or just x squared. This I can't. This is a quotient rule. Top, bottom. Top is 4x squared minus 1. The derivative of that would be 8x. Bottom is x plus 3. Derivative of that would be 1. So remember the quotient rule, it's on your formula sheet. It's just u prime v minus v prime u all over v squared. So in this case that would be 8x times x plus 3 minus 1 times 4x squared minus 1 all over the bottom, which is x plus 3 squared. Okay, you can leave it down unless they specifically ask you to put it in a certain way. But I'm going to leave it, because the space, I'm going to leave it like that. This next one. Natural log this. Now, there's a couple ways to do this. You could do chain rule. Take the derivative of the outside, which is 1 over x, 1 over all of this, times the derivative of the inside. That's one way to do it. That's actually the ugly way of doing this one. The shortcut is use your natural log rules. Remember, natural log of divide means subtract, so it's natural log of 2x minus 1 minus natural log of 3x squared plus 1. This is a short, easy way of doing this, because divide means minus in logs. Now I can take the derivative of each one separately. Remember, the derivative of natural log is 1 over the inside times the derivative of the inside. Derivative of natural log is 1 over the inside times the derivative of the inside. And there I go. 2 over 2x plus 1 minus 3 over 3x squared plus 1. That's my derivative. So one over here. This is the good old chain rule. Notice how the inside right there. So we're going to take the derivative of the outside, which is a 5. Subtract 1 off. So I'm going to get 5, 4. Leave the inside alone. then times by derivative of the inside. Derivative of this is 6x squared, parentheses, minus 3. Notice I put parentheses because it's going to be a binomial there. So I don't want to make sure, like, if you do this, it looks wrong because you're like, what's getting multiplied? Parentheses. There you go. You get that. Again, you can leave it there unless it's what they ask you. So that's some basic derivatives, right? Bring the power down, subtract one off. Sometimes you do a quotient rule. Sometimes you do a product rule. Sometimes you do some basic algebra. Those are some basic derivatives. Let's talk about some integration problems. So remember, integrations, general, everybody loves, you go the opposite way. You add 1 to the power, divide by new power. Now again, that's only for power rules. It's not going to work for E. It's not going to work for cosine. It's only for stuff like this. So like right here, I'm going to add 1 to the power, divide by my new power. I'm going to get 3x to the 6 over 6. I'll finish that off later. Derivative of cosine is actually just sine. Sorry, the integral of cosine is just sine of x. And this one, I actually like to do it separately. So I'm going to integrate right here to show you. 3 over x. I can pull the 3 out because the constant make it integral of 1 over x. That's natural log. It's a singular form if you're not sure. Plus 3 natural log of x. That's my function. And then since we have no limits, I'm going to put a plus c. And that's how you integrate. Remember, you add 1 to the power, divide by new power. Integral of cosine is sine. That's natural log. Now this next one is the reverse chain rule. So we're integrating. Now the integral reverse chain rule is you integrate the outside, leave the inside alone. Now remember, chain rule is times by derivative of the inside. Reverse chain rule is you divide by derivative of the inside. That's the reverse chain rule. So for E, that part's easy. Derivative of the outside is E. Leave the inside alone. Integral of the outside to C. And then we're going to divide by derivative of the inside. Derivative that's 1 over 3 plus C. That's my function. Next one. A lot of people overthink this one. Remember, integral of 5, a constant, just add an x to it. So 5x plus c. This one, now if you look at this one, you're like, ooh, how do I do that? It's a product rule, but not really, right? There's no product rule integration. There's no quotient rule, no product rule. If it's fancy, it's going to be u sub. So that's going to be my u. This is the same thing as saying x cosine x squared. That's my u. What we do is we select our u, use x squared. We're going to take the derivative of both sides. Du over dx equals 2x, right? Derivative du is just 1 du dx, the wrong variable. We want to get dx by itself. That's what I showed you. So multiply both sides by dx, divide by 2x. Right, just doing some algebra. Now I can plug this all in. Right, so that's gonna, you can change this with this, and the rest of it just kind of plug it in. So integral of x cosine of u times du over 2x. If you notice, this x and this x reduce. I could pull out the 1/2. Integral cosine is sine, so I get 1/2 sine of u plus c. And the last thing you do is you plug your u back in. So it's going to be 1/2 sine of x squared plus c. That's a u sub. Look at this next one. Now this one you could integrate it this way it is. I'm going to separate because it makes it a little easier for me, because when it's way more complicated I like to separate it. So I'm going to integral of this one dx minus integral of this one. So this makes it easier for me to see it. This is actually reverse chain rule again. Integral of the outside is e, leave the inside alone. Divide by derivative of the inside. Derivative of that is -1, so 1 over -1. Over here, I always like to pull out the 4, so it's going to be like this. Because it's a constant. And now I'm like, oh, it's a natural log. So it's going to be -4 natural log, leave the inside alone. Absolute values. And then, just like another chain rule, reverse chain rule, divide by derivative of the inside, 1 over 2 plus c. So I get that. I can make it a little bit prettier. -2 natural log of absolute value 2x plus 1 plus c. Again, plus c because we're doing integration and there's no limits. Anytime I see limits there, there's no more plus c. but no limits like that. And the last one is basic integration. This one right here, look at it. Look how complicated that looks. So this is a u sub again. Now, the general trick for the u sub is you want it to be the thing on the inside. You're like, oh, there's two things on the inside. There's this and this. But if you're not sure, you pick the higher one. So that's your u sub. That's our u, sorry. Our u is going to be x cubed plus 2x. Take the derivative of both sides. Du dx equals 3x squared plus 2. Multiply both sides by dx, divide by 3x squared. You're going to get du over 3x squared plus 2 equals dx. Right, the whole point of that is now I could plug this in. So instead of this dx right here, I'm going to have the same variable. I'm going to plug this guy in. So it looks like this. Integral of u square root 3x squared plus 2 times instead of dx, this stuff, du over 3x squared plus 2. These cancel, so I can rewrite it like this. Integral of u to the 1/2, because we always want to take away the radical, make it 1/2, du. And that's just a basic integration, right? I'm going to add 1 to the power and divide by my new power. So I'm going to add 1 here, I'm going to get 3/2, and divide by new power 3/2. Remember, the trick is that 2 goes to the top, so it'll be 2 u to 3/2 over 3 plus c, and then you got to plug your u back in finally. So 2 x cubed plus 2x over 3 to 3/2 plus c. And that's u sub, one of my favorites. Next, let's talk about how to do definite integrals. What's the difference there? The first thing with definite integrals, since we're doing definite integrals, that means there's limits. That's what definite integral means, there's limits. And since we're doing limits, that means there's no plus c. Right, so if there's limits, you do top minus bottom. So this is the first one. I'm just going to integrate this the normal way. So I'm going to go integral that is add 1, divide by new power, add x there. So these cancel. I'm going to get x cubed minus 1x. Now what do you do with the limits? Don't write the integration again, because that you're going to confuse yourself. You already integrated. Right thing at the end. Hey, I integrated. Now I have limits. Now all we do here is top minus bottom. So plug 3 into both of these. So 3 cubed minus 3 minus plug negative 2 into both of these. Negative 2 cubed minus negative 2. So that's something I get 27 minus 3, or 24. Here I'm going to get negative 8 plus 2, so negative 6. Double negatives make a positive, and I get 30. Right, so again, you integrate like normal. After you integrate it, keep in mind you already integrated it, so don't put the integration sign, put it on the back here. A little line lets you know I still go from top to bottom. Next one, integrate this. So integral of e to x is e to x, that makes it easy. Integral of sine of x, sine of 2x, reverse chain rule. Let's give a little moment, pause, try to see if you guys figure it out yourself. Don't disappoint me. Reverse chain rule, right? So integrate the outside, negative cosine, integral of sine is negative cosine. Leave the inside alone. And then reverse chain rule, divide by derivative of the inside. 1 over 2. I already integrated, so I'm not going to plug the integration sign. I'm going to do 0 to pi on the end here. It lets me know I set the plug the values in, but I already integrated it. Now top minus bottom, so we're going to plug pi into both of these. E pi minus cosine of 2 pi times 1/2. What says 1/2? Minus plug 0 into all of this. E to 0 minus cosine of 2 times 0 times 1/2. Now cosine 2 pi and cosine 0 is actually the same spot. It's right here. 1, 0. Sine e, cosine x. So this is going to be 1 for cosine in both cases. So this is 1 and this is 1. E to 0 is also 1, by the way. So I get e pi minus 1/2 minus 1 minus 1/2. 1/2 times that. And again, you can simplify it. Notice I haven't put plus c. Well, you can simplify. If I do distribute, let's see, it becomes a negative 1 plus 1/2, so the 1/2s cancel. I get e pi minus 1. And yes, some of you guys are screaming at me, why don't you use a calculator? Well, I could, and I'll show you right now. Right, here's my calculator. So if you want to plug something like this in the calculator, you're just going to go math, number 9, it should be f integral. You plug the limits in. right? You type in the equation 3x squared. Notice I haven't integrated it yet. If you're going to use your calculator, just use your calculator. Don't integrate. That's what your calculator does. And then you put your variable. Hit enter, and you get your answer 30. That would have been embarrassing if it didn't match. And it did. Right, so that's how you do it with your calculator, yes. But why don't we use our calculator all the time? Well, first, it might be on the non-calculator portion. And second, you might get something like this. I can't put that on my calculator, right? I can only put this, like stuff like this and stuff like that on my calculator. Not stuff with the variable right there. So how do we do this one? You do it the exact same way you always do. You integrate, ignore the 0a for now, just integrate this. This is a reverse chain rule. Add 1 to the power, divide by many power. So I get 2x minus 3 over 5 to the 5th, divided by the derivative on the inside, 1/2. I've already integrated, so I just put the limit 0 to a. Then here we just plug in a, and then minus plug in 0, so that's 1/2. Minus plug in 0 to all that, so 2 times 0 minus 3 all over 5 to the 5th to the 1/2. And whatever I get from that is my answer. That's the general idea. Okay, the next one. I'm actually erasing this because I need space. I never get myself enough space. My biggest flaw. So this next one here. So there's limit, and if you look at this type of problem here, this is actually a U sub. Look how complicated it is. Again, there's no product rule for integration, there's no quotient rule for integration. It's U sub. So your U, I always say let it be the inside, right? So it's one of these two. If you're not sure, take the higher power. So this is your U. So my U is x squared minus x. Keep in mind, your U should never be a function. Like some people do e to, no. It should always be something basic. That's my U. Now, before I move on, we can do this like normal. Find my U, take the derivative both sides, blah, 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 plug it back in, solve it, and then plug my U back in and plug the limits. Plug in the limits. Another way to do this, though, since we have a U right here, we could change these limits. So, if you have a 3 there, it's super easy to change. All you do is plug it into this U here. So, let me plug in 3. I get 9 minus 3, which is 6. So, this just turns into 6. The 1 here, plug in 1. 1 squared minus 1 is 0. So that just turns into 0. So when I do this again, my limits are going to be from 0 to 6. You're like, what's the benefit of that? The benefit of this is if you change the limits, you don't have to plug your U back in. You just integrate it and plug it in like normal. Don't plug the U back in. So let's do the rest of this. So that's my U. My du dx, take derivative both sides, would be 2x minus 1. Move stuff around. Try to get dx by itself, multiply it, divide. Du over 2x minus 1 equals dx. So plug that in. 2x minus 1 e to the u times du over 2x minus 1. These cancel. I'm going to integrate this, integrate e to the u, which is going to be e to the u. And then we're going from 0 to 6. Again, the reason I changed the limits, what's the benefit of that? I don't got to plug in my u anymore. I've integrated, I don't plug this in. I'm just plugging my new limits, top minus bottom. E to the 6 minus e to the 0, which is just 1. So e to the 6 minus 1. That's the idea. So again, if you're doing a U sub, there's actually two ways. If you're doing U sub with limits, you could U sub like normal, just like we did way up here. We got this as our answer. Then we could plug in our limits, whatever they happen to be. The way IB wants you to do, and the way most people prefer to do it, is if you're doing a U sub with limits, once you figure out what your U is, plug in your limits to get new limits. What that does is lets you not plug your U back in. Once you just integrate, you're done. Top minus bottom. Okay, last couple things with basic integration. Let's talk about these rules. So, given that -1 and 1 f of x equals -4, let's find these. So this is the first one here. Notice what they did? They switched the limits. That just negates it. So we could write -1 and 1 of f of x. Well, I know what this is. It's -4. So negative times -4 is a positive 4. Done. Look at this next one. They have a 2 in front. Well, we could pull it out. And you have to show this. You can't just put the answer down. -1 and 1 of f of x dx. Hey, now I know what this is. 2 times -4, so -8. Next one. Now you're like, a lot of people are like, oh, I know this is 4. You can't plug it in. The integral from that is 4, not just f of x. So what we do here is we separate these two. So it's going to be negative 1 of 1 of 2 dx plus the integral of negative 1 of 1 of f of x dx. We have to separate them. And now this is negative 4, that they told us. This we just got to integrate it. Integral of 2 is 2x from negative 1 of 1, top minus bottom. 2x minus 2 times negative 1. That'll give me 2 minus negative 2. So that'll give me 4 plus the negative 4. And after all that work, we got 0. How about that? Okay, last thing we're looking at today, volumes of revolution. So for some function y equals f of x, the volume created by rotating the function about the x-axis for some interval a, b is given that. So remember, this is shaping your formula sheet right here. And all it says is this, right? You get your function, square it, and times it by pi from your limits. That's it. That's the integral function. It's on your formula sheet. You just gotta go, okay, if they want me to find the volume of something, right? I'm gonna square the function, times it by pi, and integrate from my limits. So something to this effect. So find the volume solid by rotating the curve of that. So they want me to find the volume of this thing. So I'm gonna integrate it, pi times pi. My limits are from negative 3 to 3. And then my function is 2 square root of 9 minus x squared. Now remember, it's a volume formula, so we got to square it. So all this is going to be squared dx. That's my volume formula. Now let's solve it, right? So we're going to simplify, distribute that 2 to both of them. So it's going to be pi, negative 3 to 3, of 4, 2 squared, and then the square and square root cancel. 9 minus x squared dx. Now if I'm doing this by hand, a lot of people overthink this. They're like, oh, how do I do product? No. So you distribute pi. You actually pull it out also. I'm going to distribute though. 36 minus 4x squared dx. Right? You distribute. Now it's a normal problem. Let's integrate this thing. So I'm going to add 1 to the power divided by my new power. Here I'm just going to add an x. So I'm going to get pi. I integrated it, so I don't need the integration sign anymore. Then I'm going to go from negative 3 to 3. So here, plug 3 in, subtract plugging negative 3 in. And we're done. That's going to be an ugly function, so I'll just use my calculator. So that's one way to do it. There's another way to do it, though. It's a little shortcut. If you notice, this is perfectly symmetrical. These two sides are the same. So another way to do this is that you integrate, this is a little shortcut to show you, from 0 to 3 of the thing we have. But so notice I went from 0 to 3, so I just got to times this by 2. So 2 pi instead of just pi. That's a little shortcut. It's a little easier to type in the limits in this case. So if I want to integrate this, I'll put like a 2 here and I'll go from 3 to 0. It's a lot more manageable. So you do it anytime it's perfectly symmetric like this. You can always just go from 0 to the limit and then times it by 2. So it's a little math shortcut there. Other than that though, honestly, just put my calculator to the ugly number and you get your answer. By the way, something I wanted to point out, I'll put my calculator. Let's say I didn't know what the intersection was. I wanted to do it with the calculator, right? So I'd go y equals, and I'll put like 2 square roots b, right? I can't find it. Oh, there it is. Square root 9 minus x squared. Nice, you get that. You graph it. I figured out I could find the zeros. If I wanted to find the zeros. Negative 3 and 3. Now, since I already typed it in for y equals, a shortcut way of integrating this is to do this. You go to math. Let me get out of this actually. Go to math, number 9, integrate right. Let's go negative 3 to 3, times by pi afterwards. And instead of retyping it, here's a shortcut. If you press alpha, now you guys hopefully all know alpha y equals gets you the fraction if you want. But over here at y vars, so let's go alpha 4, trace. There's a y1 button, y2. So you just hit y1. What that does is it puts this equation here in for your equation. So now I don't have to retype it. It's already in there. I press X, get my answer. At some point, I'll get my answer. Sometimes today, I'll get my answer. 28.27, and I can times that by pi to get my final answer. And there we go. That's our answer to our equation there. And it's a little shortcut how to do it in your calculator. So again, from now on, I don't want you guys to if you type in y equals, I don't want you retyping it. Now, if you're just going to integrate something like we did earlier, like this, and you're not trying to find the intersection, just type it in. Don't worry about the y equals stuff. But if you have to find the intersection, a lot easier to do it, so just put y equals afterwards. Okay, that's it.